We're going to go ahead and get started with lesson 7.5. This is the lesson regarding trapezoids and kites, which are two other types of quadrilaterals. Now, let's go ahead and define a trapezoid. Let me do the following. Let me actually see if my auto shapes button. There we go. Make sure this guy's on. There we go. Here is a trapezoid. This is what makes a trapezoid by definition. Okay. There are parallel sides in one set when we have a trapezoid. So this is what trapezoid is. Let me get the typing tool so we don't have to live with my handwriting. This is a little bit more legible. But a trapezoid is a quadrilateral with exactly one pair of parallel sides. And the parallel sides are called bases. Now, when you guys were learning about parallelograms, there is two sets of parallel sides. This is just one pair. Here are the other parts. So this guy right here, this parallel side and this parallel side is called a base. A base is big base. And then they have these angles, which are paired together. This is a base angle. Okay. And then this guy's a base angle as well. Each of these sides. And then right here, the non-parallel sides. These guys are called the legs. All right. We can have a specific type of trapezoid. Okay. And this is one we're going to actually discover where, again, it's a trapezoid, but then if our legs are congruent, this is what's called an isosceles trapezoid. Where the legs are congruent. Okay, pretty straightforward. So now let's examine the proof of doing this as we calculate. So you guys remember this whole world of quadrilaterals that we have, right? So the question then becomes, is it a quadrilateral? And then we're going to figure out, is it a parallelogram? All right, and we have two options over here, which is it's a yes or a no for parallelogram. We have our test to do that, which we're going to take the midpoint of the diagonals. And then if it's a yes, we have to determine, is this a rectangle? Which will take the distance of the diagonals, or is it a rhombus? Which we're going to take the slope of the diagonals and to see if the distance is congruent or if the slope is perpendicular. Okay. And if the answer is yes for rectangle and yes for rhombus, then this is a square. All right. If we get that it's a no and a no, okay. Oh my gosh, this is crazy. This thing just went. Then this is a parallelogram. Okay? And we just call it a parallelogram. So, here's the other part of it. What if we have it as a no? All right. We have a whole new set of contingencies. We could potentially have a trapezoid, or we also could have a kite. All right. So, to find if it's a trapezoid, here's what we have to do. We're going to figure out if it's a yes, no on trapezoid. Now, we're going to test the slope of the opposite sides. Okay. Now, when we find the congruent slopes, those are going to be parallel, and that's going to be my set of bases. Okay. Now, if none of them match, actually, as soon as a pair of them match, we don't have to keep calculating because it's impossible for the other two to match because if it did, we'd have two pairs and that would be a parallelogram. Okay? So using our logic. Um, after, if we actually get the answer of yes, we actually have to test one more thing is we have to see, is it isosceles? And what we're going to calculate here is we're going to take the distance of the legs, which are the non-congruent slopes. Okay? Before we move on, we're going to have to come back here and think about, uh, for kite. It's going to be a consideration for later in the lesson. Okay, so I'm just start this guy. Something we're going to have to come back to. All right, so let's do a little example here with our crazy decision tree, a la as I discussed with you guys before the COVID-19 pandemic when we had these decision-making trees that dictated if we were gonna get to go to work or school that day based upon your exposure to a symptomatic or even an asymptomatic person um, with that virus. So, what is quadrilateral ABCD? Well, let's figure it out. Okay. Do we have to do the midpoint test? And the answer is again, it's a quadrilateral. So the first thing we're going to do is test if it is. If it is a parallelogram, right, then we know it's not going to be a trapezoid. These are mutually exclusive. So let's find the midpoint of the two diagonals. The midpoint of AC. Find the midpoint of BD. The midpoint of AC. We're going to have -2 plus 3 is 1 over 2. We have -1 plus 2, which is 1 over 2. BD, 0 plus 4 is 4 over 2 is 2. And then, and actually, we already know they don't match, right? And then 3 minus 3 over 2 is going to be 0. So this failed the midpoint test, okay? So what do we know here? This is not a parallelogram. So right now, we're in the world of, is it a trapezoid? Or is it just this is just a regular old quadrilateral, okay? And then we'll be able to test later about if it's a kite, and we're going to give you that test. So now we need to find some slopes. So let's do the slope of AB. And you know what? Let's do the slope of BC, the slope of CD, and the slope of AD. Now, which ones are going to match up? That's the question. When we know AB and CD and then BC and AD. Okay, so let's do our calculation here. I'm going to have 3 minus 1 over 0 plus 2. Oops. Which is 4 over 2, which is 2. Okay. For BC, I have 2 minus 3 over 3 minus 0, which is going to be -1 over 3. Okay. For CD, I have negative 3, oh goodness gracious, minus 2 over 4 minus 3, which is -5 over 1, which is just -5. So far nothing's matching, okay? What would have to match is BC and AD, because AB and CD don't match. So, here we go. If these match, then these are the bases. So -3 plus 1, and then we have 4 minus 2, or 4 plus 2. So -2 over 6, which is negative 1/3. There it is. So, okay, these two match. What this means is AD and BC are bases. Okay, Moreover, what's important is that AB and CD are the legs. Okay, and that's what's important here because if these guys are the legs, this is where I have to demonstrate back up here. If it's a trapezoid, is it isosceles? So I need to find the distance of those legs. All right, so here we go. I think you guys, if you remember, you can kind of recycle a little bit of your work here when it comes to slope and distance. So AB, right? So we had 0 plus 2 squared plus 3 plus 1 squared, right? So this part, I'm just going to put that inside and square them, which is going to give me 0 plus 2 squared is 4 plus 3 plus 1 is 4 squared. Oh, gosh, this guy's doing all sorts of weird corrections. 16, so this is going to be rad 20. For CD, okay, I'm going to have negative 3 minus 2 squared plus 4 minus 3 squared, okay, right, just recycling this work. Negative 3 minus 2 is negative 5 squared is 25, and we already see where this is going, right? This isn't going to work. 4 minus 3 is 1, squared is 1, so rad 26. So we know this is not isosceles. All right, this is just a regular trapezoid. Okay. All right. More characteristics we have here. More things to define. For when we have that isosceles trapezoid. Couple things. The pairs of base angles are congruent, and diagonals are congruent. So here's another way for us to look at this, right? Here's a calculation that's going to come up shortly. And it has to do with the kite, okay? Moreover, and I'm sorry, that we've already gonna have to do anyway. If no matter what we do, if we get to the non-parallelogram, if the answer is yes on parallelogram, wouldn't we take the distance of the diagonals anyway to find rectangle, right? So we could also do the same thing for isosceles trapezoid. So something to keep in mind. But let's go ahead and mark this real quick. If this is saying that we have these two are parallel as bases and these legs, right, are going to be congruent, it means that this base angle and this base angle, these pairs are going to be congruent as well. All right? So, next up. This should be one that you're going to hope to have on your upcoming test next week. ABCD is an isosceles trapezoid. And the measure of angle A is 42. We're going to find measure of angle B, measure of angle C, and measure of angle D. We weren't given any picture. Okay, so here we go. Let's go ahead and make this, right? Oops, that's made a rectangle. So A, B, C, D. And I know A is the acute angle because it already told me right here, this guy's 42. Okay. Well, I can figure out everything else here because remember, this guy and this guy are congruent. This guy and this guy are congruent. So I can figure out that angle D right away is equal to 42 degrees. Okay, that should be pretty straightforward. And then remember, if these are parallel, well, what I have here is I have a parallel cut by a transversal, meaning that angles A and B are consecutive interiors, right? So I can just say that since these consecutive interiors are supplementary, I can just back that out from 180 and get 138 degrees, which means the measure of angle B is equal to 138. And hey, remember B and C are the same, so angle C also has to be 138 degrees. Okay? So pretty straightforward. Circle my answers. All right. Next. Here we have a trapezoid. This trapezoid is named ABCD. It is not isosceles. But since AB is parallel to CD, because those are the bases, there's one more thing that I want us to explore. We're going to have one more segment to consider here. And it's where we take the midpoint, and I'm going to call this M of AD, and this midpoint, and this is going to be N of BC. And if that's a midpoint, right, it means that BN and NC are congruent, and AM and MD are congruent. BN and NC, my apologies. So, one other factor here is that this is what's called the mid-segment. Okay? The mid-segment is also going to additionally be parallel to those lines. Moreover, that line's length is equal to the average of those two bases. So 1/2 of AB plus CD. Now, there is actually kind of a shortcut way to do this. I'll actually show you guys using the formula. But I want you to really take a look at what I'm going to do here. And I'm okay with you guys kind of shortening things up to this, okay? So here's my trapezoid. This is my trapezoid X, Y, and this is a new formula, problem here. X, Y, this is WZ. Here is my line. This guy's J, K. Okay, and here are my parallel bases. This is 9. This is 15. Okay, and what I'm told here and given is that JK is the mid-segment of trapezoid W, X, Y, Z. Okay, what does that mean? Well, we're going to find JK here. Now, I'm going to do the formula here, right? So this mid-segment is going to be equal to half of the sum of those other two numbers, right? So in other words, JK is equal to 1/2 of 9 plus 15, right? 9 plus 15 is 24. So JK is equal to half of 24, which is 12. Now that's a lot of work to get there. Also, take a look here. What's halfway between 9 and 15? Well, it's 6 between the two of them, so this is just going to be 3 more. This is going to be 12, okay? Moreover, there's another way to do this. I'll show you guys in class. So, for example, if I have another trapezoid and I have a mid-segment, oops. Okay. And this is my trapezoid. All right. I'm going to give you guys, oof, Jesus. This is a little messy. If this is 3 and this is 4, the last base would have to be 5. Okay. Or if this is 3 and then the mid-segment 6, right? That last base is going to have to be 9. It's going to be 3 more. If this is 3 and this is 13, the next one's going to have to be, right, 23. It's just going to be, this was plus 10, so you should add 10 more. If you guys remember, we did some stuff with midpoints earlier in the course. Works the other way too. Let's say this is 10 and this is 6, right? 4 less is going to be 2. So just a couple little examples for you guys. All right. Um, let's move to the last part of the lesson and talk about kites. All right. Long lesson for you guys here. A kite. I swear to God, this is the actual name of it. It's not just something from Mary Poppins. A kite is quadrilateral. Has two pairs of consecutive congruent sides, but opposite sides are not congruent. Okay? Looks like this. Oops. This is my kite, okay? Not a diamond. Doesn't exist, all right? So, few things. One, the diagonals are perpendicular. We can calculate that, right? We can take the slopes of the diagonals in a coordinate plane and calculate that and see if they're negative reciprocals. And exactly one set of opposite angles are congruent, okay? So it's this. It's going to be the ones that are going to be that are going to be in between these two. Because take a look here. That's what's going to happen. I'm going to have that reflexive side, and then I have side, side, side. So then these angles right here are going to be corresponding angles. They'll be the corresponding parts. Okay. Real quick, let's go back to the very beginning of our notes. For kite, we're going to take the slope of diagonals. So if we know that we have a non-parallelogram, we could check the slope of the sides and actually the slope of the diagonals as well and figure out, is it a trapezoid? Then is it a kite? And actually, you know what's also quite possible? It will just be a plain Jane quadrilateral, none of the above. Okay. Something we'll discuss a little bit more right before your exam. Last thing, here we go. Oh, gosh. Undo that. Here. Let's connect that guy there. Here's my kite. Okay. This is kite ABCD. And I'm given the following. This is an 80-degree angle. This is a 50-degree angle. And we're trying to find X. Okay. So we're going to find what the measure of angle C is. So what we know is because these are these opposite angles right here, right, of the two consecutive non-congruent sides, right? Because these guys are consecutive congruent. So this guy is just going to be left alone. We know that this and this have to be congruent, right? As we could do through a triangle proof, as I did very briefly. So it means that X plus 80 plus X plus 50 is equal to, what's the interior angle sum of a quadrilateral, right? It's that whole n minus 2 times 180 thing, right? Or we can just maybe have it memorized, which is 360 degrees, okay? Or in other words, 2x plus 130 is going to be equal to 360. So 2x is equal to 230, meaning that x is going to be equal to 115. So measure of angle C, which is congruent to x, is going to be equal to 115 degrees. All right. Thank you, Saintsman. If you have any questions, of course, come see me during office hours.